All right, we are factoring using the area model, and so if you can remember, area is essentially length times width. So we're going to be using something really basic, really elementary, length times width, and apply that to factoring. So before we get into that, let's look at just a very basic example. We're going to take the area for each of these boxes. So for this first box, we've got a length of 15 times a width of 15. So 15 times 15, the area of this first box is 225. Next we have a length of 6 times a width of 15. The next area would be 90. Here we've got a length of 15, a width of 4, so that area would be 60. And then for the last box, we've got a length of 6 times a width of 4, and that area would be 24. Now, to find the area of the whole box, we would just add up all of the boxes. And that would give us an area of 399. Okay, just to break that apart a little bit further, if we were to add 15 plus 16 for our whole length, and I'll use a different color, 15 plus 4 for our whole width, we would have 21 times 19, and that would also get us 399. So this concept of if we break it apart and add our lengths and add our widths and then multiply, we would get the same areas if we added up all the boxes. So that'll come in handy when we're doing actual factoring. Before we get there, we're going to baby step and do this problem, same thing, area. So for this one, we've got a length of x and a width of x, so that would be x squared. When we multiply x times x, we get x squared. Here we've got 6 times x, which would be 6x. Here we've got x times 4, which would be 4x. And last one, we've got 6 times 4, which would be 24. So again, to get the area of the whole box, we would do x squared plus 6x plus 4x plus 24. And so that would be x squared plus 24x plus, oops, I just messed up there, plus 10x plus 24. We're just combining these like terms. So what we're doing today is we're basically doing the backwards version of this, multiplying length times width. We're going to be figuring out what the length and the width is given the area. Notice here before we start, this top left box has x squared in it. This bottom right box has just a number in it, a constant. And notice here for our final answer, these two boxes added together give us our middle term, 10x. So that will become in handy when we're factoring. Okay, so for this first problem, we have x squared minus 5x minus 24. And we know this first box is going to have x squared in it. This last box is going to have our constant negative 24. So we know the only way to multiply to get x squared in simple terms, there's multiple ways, but for our sake, we're just going to do x times x. We need to figure out what's going to go here and here that will add to give us negative 5x, or sorry, negative 5, and then multiply to get negative 24. So different things that multiply to get negative 24 would be 1 times 24 with one of them negative, 2 times 12, 3 times 8, 4 times 6. So one of those with a negative in there should give us a negative 5x. So because we have a negative, we know it's going to be a difference. So we know it's going to be 3 and 8. So I'm going to go ahead and put 3 and 8 here. So when I multiply 3 times x for this area here, we're going to get 3x. And when I multiply 8 times x for our area here, we're going to get 8x. And since we need a negative 5x and a negative 24, we need the 8 to be negative to give us what we want. So the factored form of x squared minus 5x minus 24 would be x minus 8 and x plus 3. And you could switch these whole parentheses, it doesn't matter. All right, for this next one, x squared plus 6x minus 27. Same thing, we're going to put x squared here, minus 27 here. To get x squared, we know it's going to be x times x. To get negative 27, we could do 1 times 27 or 3 times 9. We want whatever is here and here to add up to positive 6. And we also want those two numbers to multiply to get negative 27. So we know it's going to be 3 and 9 because of this difference of 6. And we know it's a difference because of the negative 27. So let's see. If we have area of this box, we're going to have x times 3, which will be 3x. Area of this box, 9 times x, which would be 9x. And since we want a positive 6x, we want 9 to be positive, 3 to be negative. So we'll put a minus sign with our 3. And factored form is going to be x plus 9 and x minus 3. All right, we're continuing on. Here we do have a 2x squared, and we're going to have a plus 2 here. So when we have this 2x squared, it's going to affect our boxes a little bit. So we're not going to be doing x times x. We're going to be doing 2x times x. You could also flip it and do 2x and x. Like, you could flip these, doesn't matter. Okay, so now we want to multiply to get 2. So that'd be 1 times 2 or 2 times 1. And we want to have a negative 5x here. So we'll figure that one out later. But because we want a positive 2, we don't have to think about difference anymore. So we could either put a 1 here and a 2 here or vice versa. If I leave it this way, I'm going to have my area for this one would be 2x, and my area for this one would be 2x. And when I combine these two, I get 4x, and I want 5x. So hopefully you can see that one's not the right order. So I'm just going to back up and put 2 here and 1 here. So the area of this box would now be 4x, and the area of this box would be 1x. We want to multiply to get a positive 2, but we want to add to get a negative 5. So to do that, we would need these to be all negatives. And now you can see these add up to negative 5x. I'll highlight so you can see that better. Those add up to negative 5x, and I'll use pink on this one. This one multiplies to get 2. So the factored form of this one would be 2x minus 1 and x minus 2. And note that you can always check your work by distributing that out, and you should get what we originally had. All right, last one, we've got 6x squared and negative 5. We want to multiply to get negative 5, so luckily it's just 1 times 5, and one of them is negative. The tricky thing about this one is we could have 6x and x, or we could have 2x and 3x. So this one we might have to do some guessing and checking. So let's start with 6x and x. And we only have 2 options. We've got 1 and 5. So if I do 1 here and 5 here, this would give me 6x and 5x. And these two would add up to 11x, and we want 13. We do want one of them to be negative, so if I put a negative here, that'd be a negative 1 combined. If I put a negative here, it would be a positive 1 combined, so we know that this is not correct at all. So let's flip-flop and put a 5 here and a 1 here. When I multiply, I get 30x and 1x. When I combine these, I get 31. I do want one of them to be negative because of the negative 5. Here, that would give me a negative 30x and 1, which would be negative 29x. We know that's not right. If I put a negative here, it'd give me positive 29x. We know that's not right. So now we go all the way back. We're going to erase these, but we also know that 6x and x is not right either. Oops. We know it's going to be a 2x and a 3x. So let's try 5 and 1 and just see how that goes. So this would give me 10x, and this would give me 3x. Combined, this does equal 13, but we do need one of these to be negative, so we'll try negative 5. And that would give me a combined of negative 7x, so that's not right. If we put a negative here, that would give me combined of positive 7x. We know that's not right. So we need to flip our 1 and 5 completely. So I'm going to put a 1 here and a 5 here. If If I find the areas, I get 2x and 15x. Combined, they give 17, but luckily we need one of them to be negative. So if I just try that one to be negative, I would have a combined 13x, which is what I wanted. So that was kind of fast, but in the end, my factored form would be 3x minus 1 and 2x plus 5. We basically were trying different things to get our 6x squared. And then after we discovered 6x times x didn't work, we were trying things here and here. That maintained our negative 5x, but we needed the combined diagonal to be positive 13x. So we had to do a lot of guessing.